We're pleased to have Santosh Kandel talk to us from the California State University at Sacramento. I was almost going to say the University of California at Sacramento, then I would be in trouble. And what we're going to hear is projects that engage students in differential equations. This conference is built on that theme, and we love to hear these examples. So Santosh, we'll turn it over to you. Okay.
Yeah, thank you, Brian, for the kind introduction. And first, I would like to thank the organizer for such an amazing event. I'm new to this space and I have been learning a lot. And I really want to thank you for that. And I also want to thank you for giving me this opportunity to share my experience with some of the ways like I'm implementing projects in my differential equation class. Just to give a background, I think like I want to take a step back and just talk about uh, the institution here. So we are here in Sacramento. It's a large public university. And we have diverse student population. And also like we are designated as an SSI. On top of that, an Asian American, Native American Pacific Islander serving institution. So that is like sort of like the background, and a lot of our students, they work outside. We have like slightly non-conventional students as well. And let me just try to go to the class, the differential equation course. So it is a service course, especially for engineering and physics and other majors. We have about 10 sections per semester and about 25 to 30 students per section. And again, since it is a service course, it is basically, we get engineering students, physics majors, and sometimes we get math majors as well, but very rarely. And traditionally, the focus has been on solving ODEs. So just taking a step back, this our differential equation course has calculus 2 as a prerequisite. So usually students take calculus 2 and then come right after calculus to the differential equation class. So that is how the course is, the department syllabus, and that is how the course is structured. And it is looks like an extension of calculus rather than in essence learning about the differential equations. So, and for that reason, there is a very minimal focus on modeling aspects of the differential equation, and which is kind of sad in a sense that this is an opportunity we can teach students some practical aspects of the mathematics basically. And that is where like I'm coming from. And personally, like my background is, and I come from pure mathematics. So I have, less applied math background. And for that reason, I did not know about this space at all. So basically, this space. So I taught this class in a few years ago for the first time. And I followed like the department approach, their syllabus, and it felt really, really dry. It did feel like, the calculus extension of the calculus. And usually students do not have very positive experience in the calculus. They were doing problems, but, at the same time, it did not feel like they're having a good experience with the class itself. So my motivation was to sort of increase like the student participation in the sense that they engage with the material and they take something away from the class. So that was like one of like my motivation, and also like making a connection with the real world. So basically we do calculus, we have all these foundational things, and they have like amazing application in the real world, wherein students sort of like they are very much disconnected. They just think of okay, like doing at this stage, they just think of doing mathematics as solving some integral, solving some differential equation, and they do not understand like how it connects to like some other aspects and some real world problem solving. And also like I realized in math we always have this problem with the communication and also like with the collaboration, and we want to be sort of isolated, and also like we do not communicate very well, and that is another thing I wanted to improve upon. And probably like my must like like top of the list personal goal was to encourage problem solving and reasoning, and thinking about not just like doing the problem like the using like certain method, just do some integral. Just think of like the problem solving. There are like certain stages to the problem solving. First of all, we need to understand the problem. That's the first stage. And then we need to know how to sort of come up with a strategy to solve the problem, and then also like think about whether our solution is like connected with the problem. So we started with developing this kind of things. That was like my top of the list goal, and also like the facilitate peer learning, working in a group, teamwork, and that kind of stuff. That is where like I'm coming from. So again, I always had like this wish list after I taught this differential equation for the first time, and I was not finding like the kind of material I wanted. I wanted to incorporate these things, but I did not know how to get started with. So that was like the challenge I was having like in the beginning. So I started, looking into the internet, and then, how people implement the projects and stuff. And unfortunately, I could not find similar because my background was in pure mathematics. So what I found was something called project-based learning, and I did not know like there was a whole pedagogy system called project-based learning, and it was huge. And that is where like I was deviated in the beginning. And I went for a workshop in summer, and let me just say a few things about this project-based learning, even though like I will not be completely talking about project-based learning in this talk, but I think it is a good thing to know. At least, I was very pleased to know about this thing, and I'm just going to share with you that. So it is a pedagogy that focuses on, using projects to enhance learning experience, basically, connecting with the real world thing, meaningful thing. And to say like, a few more good words about project-based learning, like it emphasizes theory and practice together, not theory and then practice. Also like engages students in more hands-on learning experiences. Again, it has a lot of good things, encourages collaboration, help people to understand like some unstructured problems, because in math, we are used to thinking about very structured stuff. And it has like all good things, and on top of that, cultivates confidence, leadership, and critical thinking skills. So I think like I learned, and I'm still learning. Okay, so I'm not an expert in project-based learning. Like I'm still learning about it, but there seems to be quite a few literature, which have like really good things to say about this project-based learning. For example, it has good impact on retention rate. That a study by Koo in 2012. Also, it cultivates sense of belonging, fosters supporting environment, and the crucial part is also like helps like closing the equity gap. There seems to be a lot of researches around here. Now coming back to again like this project-based learning. So this is like when I went to a workshop, like they gave us like some framework about how would you start designing the projects for your class, and they gave us like some components of this project design. So we have to like keep some of these things in mind. For example, the questions should be interesting. There must be sustained inquiry. We want like some authenticity. These are like sort of like the guidelines, they say like these are the components of the project design, but I took them as guidelines and according to our like the student population, our need, like I just took them as sort of like the guidelines for myself. And then when it comes to practices, like it is expected that, we incorporate, like some of these elements in our teaching practices when we are implementing projects in our class. For example, like the design component, and the important thing should be we should not deviate away from our learning outcomes, whatever, like however we design project, it should sort of, align with our outcomes. And for me, like, like this giving feedback aspect of the project-based teaching practices, and it resonates a lot. So basically, a lot of good things here. So now coming back to my own class, like I just want to deviate, there was like something about the project-based learning I learned and I wanted to share. Now coming back to my own class. So I did when I did for the first time in fall 2023, I did in first, I did some projects for the first order equations, and I also did for the second order differential equations. And I just want to talk about the second order differential equation here, basically. So for the implementation, so the overview was students just explore like some applications of second order differential equation. And just to now take a step back, and I use the textbook by Dennis Gill. So for my class, and I think I really find that book interesting, and it also has a lot of like the application-based problems, I think, like in the book, that is what my motivation was. And now recently I learned, the another book, and I think like I will take a look at it from, yesterday's workshop. So for the practical aspect of the differential equation. But that is the book I'm using, like the personally, and all of the projects, like I am taking it exactly from that book. And I just wanted to mention that before I forget. So again, the overview is just exploring the second order differential equations, and then a student would conduct a mini research and then write a report. So this is like sort of like the overview of the project. And just going to the project itself, like the main components were, so the introduction, give a background, some context of the problem they are choosing, and explain the motivation behind, choosing the problem. And then the next stage was, and the next part was development of the mathematical model, formulate the problem using differential equation, also describe the process basically. I'm more like interested in the process of developing the differential equation. I think that is where this modeling thing is going to come in. And then the next stage is analysis of the model, and then extract information from the solution basically. Solve, like sometimes we may not be able to solve the differential equation, but we can try to extract the information from the solution. And then finally, like, okay, the interpretation of the solution. So basically, so those are, and the guidelines, this is like, those are like the components I wanted, and these are like some guidelines to the students, basically how they, because these students are coming out from the calculus, and a lot of students are not used to with this project idea in mathematics class. And already like in math, in including the project at this stage is slightly unconventional. So for them, so I wanted to give them some structures so that it helps, it gives like the positive sort of like message, rather than they get overwhelmed with like what to do, how to do kind of thing. And I provided like some sort of like the guidelines to them, some directions to them. And okay, to do this thing, and the all those four components I mentioned in the previous slide. And here, they would add also like contribution from each group member, just to make sure that everyone is accountable in contributing to the project. So here I'm just going to share like few projects I did. So the first one was I'm just using like the two examples. There are a lot of things like, like a lot of other projects, like, and I just want to share like the two examples here. Yeah, this project was the modeling the spring mass system with the driven motion. But just to give you a context, so in class, like we had gone through like some of the application-based problem before we did this project. We talked about this free undamped motion. We also talked about free damped motion. We went through like the derivation of those equations. We talked about, we solved the equations. We discussed the we interpreted the equations, we drew some graphs, that was done. And we also did like some other problems like circuit problems, some of the application problems were already discussed before students started this project basically. So I did not do this thing in the class, and I wanted them to explore this project. So that was like sort of the idea here. And this is like the one of the work, the project report from the student. The introduction was not like as good as I expected, because the student chose just to give a mathematical introduction rather than connecting with the context. So this is what the student work is. And they went on like, doing a bit, it was like sort of like the more mathematical minded writing, I would say. They went on talking about the notations here. They set up the stage, like talk about all the notations involved. And they also give like some background information, like what are the kind of things they are going to need, the ingredients in order to develop the model. For example, they talk about the Hooke's law, and they also discuss about Newton's second law of motion. And then they go on talking about they're developing the model, basically give like some details on it, like how they are using this Newton's law of motion to derive the model. So this is what they do it here. So that is the model derivation part. And then they go on like talking about how would they solve so the system basically. So here, and I think like the students provided much more detail about how the student would go on about solving the differential equation. uh so this is dividing this complementary and then the particular solution part, and then the student focuses on solving the homogeneous part of the differential equation, and then discusses in a very abstract form actually, and then talks about the complementary solution, the homogeneous solution of the homogeneous part in a detail, talks about when it is critically damped, undamped, strong damping basically. It talks about it, and then the student goes on solving about the non-homogeneous differential equations. So basically, so this is what I'm showing here. I think like the solution. And then they do talk about practical scenario, but I think like this problem probably they took it from the textbook and then tried to solve it. They thought, and this is the practical scenario. Maybe like, this is not what I was hoping for. They do talk about this thing and then go on sort of analyzing like how the solution looks like. So this is one of the projects. And I took it from the book, as an extension of the things I discussed in the class, for them to explore on their own terms, what it does it means to be adding this extra force when you're talking about this like the spring mass system. And then finally, they do also talk about the limitations of the model, and it can come in a variety of ways, starting from the Hooke's law, and then like they're making a lot of like strong consideration on talking about the damping force. They do talk about on this kind of stuff. So this was like the one of the projects I did. And this is like when I taught for the first time, and I learned a lot from, here. And then I will show you a recent one, another example. So, okay. So that was fall 2023. And now, this is fall 2024, this examples. And here I made some changes because I will talk about my reflection at the end. I made certain changes. So in this part of the project, we did slightly differently. So we did in certain stages. First of all, we just focused on understanding what the problem is, what kind of problem like we are dealing with. And then after like in the next stage, we went and developing the model. And in the next stage, we solved the models and then started giving the interpretation. That is we did in stages rather than doing the whole like the project at once, because I feel like that was not very effective from my personal perspective. So here, they talk about the introduction, and this introduction, they provided tiny bit of details here compared to the previous one. And then they go on talking about, the model derivation and analysis. So they start with this growth model, and then they talk about, there are limitations to the growth model, and they go on improving to get the logistic model here, basically. So they go in stages here. So this project was not very nicely written, but I was very happy with the project because Instant actually did a lot of analysis, and they studied like the solution, what happens when you change the initial population, what happens when you change the rate of the growth. They did a massive analysis here, which was, and talking to them, they told me that actually it was very nice for them to see in like if they can plot the solution and they can interpret the solution and they can expect what happens, and the reality is matching in certain degree with the solutions they are getting here. So this was another project they did, and they do a lot of analysis. So yeah, so these are like the two examples, and I think I wanted to share. So basically, and again, these examples are taken from the book because it was easier for me to sort of like implement it, not knowing a lot of resources out there. But when I have to do it again now, I'm doing in this fall, I'm looking for some other resources, for myself, and that is why I'm here in this conference. All right, now back to like sort of, like the talking about my experience. So I just want to start with the student perception first. So again, like the implementing this thing is slightly different, like for our culture of mathematics here in my institution. So I got like the mixed sort of like the response from the student. Some students really liked it because, they were engaged. For some students, it was a different thing. So it was slightly more challenging. For some students thought, okay, so these problems are already out there. We are not doing anything new. And so it was not that challenging for them from that point of view because they are not contributing anything new to the science. So there were like different kinds of students, and there were like a different kind of like the opinions from the student. And other thing was that this group collaboration had like the positive and the negative sort of like the dynamics there. Some people really like to work in a group and they learn from each other, from each other's strength. They divided the projects into several, so certain people would do the introduction, other people do the interpretation. So they had like the good group division. It went work good. In some teams, some people were not contributing as much as they were supposed to. So there were like some group dynamics thing. I think like that will always come up. And the other thing, different thing was that they found it's very unconventional writing a project report. So it is very, very unconventional for them, writing a report in a math class. And I thought it was positive because, they were first to sort of like they communicate their thought process with like the other people, at least like with me. So basically, so it was a good thing for them, like the reporting part of the project. And the personally, like I think when I was implementing this thing for the first time, I went to this workshop on project-based learning, and I was just like so much driven by the theory of the project-based learning, and I was like very ambitious, I would say. So I learned a lot, I instead of taking a small step, and I made the mistake of taking a big step at a time. So it was like I feel like the project was very, very ambitious, but now I'm learning and learning and learning more, like I'm implementing differently. So I hopefully like the things will get in the future. And the second aspect is the group collaboration. My experience has been this is always like there will be like when we do the group project, some issues will always come up there. So I'm just handling slightly differently. If the students do not want to work in a group, I'm allowing them to sort of work individually. I think that is okay. I want them to have career ready skill, but at the same time, I respect, their comfort as well. So my main goal is they learn the modeling aspect of like the differential equation. They learn to think mathematics slightly differently. And having that said, and I think like the one positive thing is, like whether student liked it or not, there was increased engagement with the course material, and students were paying more attention to like the course material when they were solving, like thinking about the solutions of the differential equation after they solve. It was like the more positive engagement with the course material actually. So that was like really good thing for me, and that encouraged me to continue like this kind of practices for my future teaching. And finally, yeah, so here are like some references I use for the project-based learning, some references. And I think like that is all I wanted to say. And thank you so much, for the opportunity. And I'll be more than happy to answer if you have any questions.
Well, thank you very much, Santosh, and for your